So this was the big late decision in the Raiders game. The Raiders down 10 late. They need two scores, a 3 and a 7. We don't need to worry about the conversion decision right now. They need two scores. One's a field goal, one is the end zone. What order are you going to get them in? The Raiders get to 3rd and 3 right here. They don't convert. They get to 4th and 3, and they decide to kick. Was that the right decision or not? It wasn't. I actually don't want to spend a ton of time on the calculations, but I will show those right now. I want to spend most of the time on discussing the decision-making framework that coaches should be using, but they don't. But here, first of all, this is how you can win either way. If you're going to go with the field goal right now, this is how you win. You have one way. You get the field goal, you're down 7, you get the defensive stop, you're still down 7, you get the touchdown to tie it, and then you win in overtime. You have one way to win. You have two ways to win, this top row and this bottom row, if you're going to run a 4th down play. Now, both of them are contingent on these first two parts, getting the 4th and 3, and then scoring after that. So if the 4th and 3 picks up exactly 3 yards every time it's successful, TD.7, you have to score a touchdown starting on the 7. So you need both of those things to happen. Yes, if you don't pick up the 4th and if you don't get into the end zone, you're not going to win. You need those two things to happen. The two ways to win, if those happen, you get your defensive stop so that you're down 3, you kick a field goal to tie it, and then you win in overtime. That's one way. Or you could get your defensive stop and you could score a touchdown to win it outright in regulation. There is a way I'm not mentioning. It would be to allow a field goal. So you score the touchdown, then you're down 3. You can technically allow a field goal, be down 6, and then score a touchdown for 7 to win it. The thing is, in most cases, that's a difference. In this case, it's not, because if the Bengals get into field goal range, they're probably going to run the clock out. So you don't just need a defensive stop. You need a defensive stop quickly, and I'm going to show that in the calculation in a second. So if we get to the next slide here, just some numbers that I'm going to input. First of all, getting the defensive stop, I went with data from this game, and I said 2 out of 7. It was just about 7 drives the Bengals had, and only about 2 of them did the Bengals have to punt very quickly. And that's what I'm saying. If the Bengals get like really any amount of first downs, take any amount of time off the clock, the Raiders are going to run out of time. It's not just enough to like allow the Bengals to go 35 yards and then force a punt. That's not good enough. Time is going to run out on them. So they need to force like a 3 and out almost. So that was about 2 out of 7 times the Raiders were able to do that in this game. Also, overtime, I say 50-50. So we have those numbers. Next is the field goal that the Raiders are trying in this picture in the background right now. We can't say 100%, but it's so short we could say something close to that, like 98%. Next is the Raiders scoring a touchdown if they force that defensive stop. And I looked at how often the Raiders moved the ball so much this game that they got a touchdown. They had one actual touchdown, and then they had all those field goal drives that fizzled out. So they didn't get into the end zone, but of those field goal drives, none of them were 4-down territory. They would at least understand this is 4-down territory. So some percent of those field goal drives, if they were going 4 downs the whole way, would get into the end zone. So I went with 2 out of 7 for that also. 1 for the actual touchdown drive, and then all those field goal attempts that they tried, maybe one of those, if they went 4 downs the whole way, would get into the end zone for 2 out of 7. And the last thing is if the Raiders got the 4th and 3, got into the end zone to cut it to 3, got a defensive stop, what if they just needed to get into field goal range to force overtime? I went with 80% because most of their drives were field goal drives. That was their problem. They were scoring a lot, but it was mostly field goals. So to just get enough yards after forcing a punt on a 3 and out, it's actually what the Raiders were doing all day. So this is fairly high, but that's what I thought the Raiders would be able to do if they got the ball back about 80% of the time, get into field goal range and force overtime. So that leaves one thing before we solve for how often they need to be getting their 4th and 3. It leaves, what if you pick up the 4th and 3 and then you have to get in from the 7? And you could look at it this way. Imagine on any individual play, and I wrote from the 5 here because we don't know that the 4th and 3 conversion will pick up exactly 3 yards. I mean, it could pick up like 4 or 5 yards. So first and goal from around the 5, maybe, the 4, the 5, the 6, or the 7. How often are you going to get in? Think about any one play. And if we say any one play is 25%, then we could look at it this way. On first down, you'll get into the end zone 25% of the time. On second down, that would mean you fail on first 100% minus 25%. So you fail on first 75%, but then you get in on second 25%. Third down would be fail on first, fail on second, get in on third. Fourth down would be fail on first, fail on second, fail on third, get in on fourth. So this is how we could look at it. Then we could do the multiplication, and then we could add. And getting in after you get the 4th and 3 would be about 68%. So we could go back to our calculation. We could plug in the 68%. Now we just have one variable. So we could do all the multiplication, get these numbers cleaned up a little. This is where we get to. On the bottom, we could slide that to the right, and then we could factor out the probability of picking up the 4th and 3. So it looks like this. We could add the numbers in the brackets so that it looks like this. And now we just set both of these equal to each other, and we get this. And it's just very easy. Divide both sides by 0.1332. We get to here, and our probability of picking up the 4th and 3 needs to be 0.30, which is 30%. So this is the break-even point. If you think you're more likely than 30% to pick up the 4th and 3, you need to be running this 4th and 3 play. If you think you're less likely than 30% to pick up the 4th and 3, you should be trying the field goal attempt. The thing is, 2-point conversions are basically a 4th and 3. It's 2 yards to go. It's from a very similar part of the field, and those are usually in the high 40s. So I don't know that there's any coach out there who would say on 4th and 3, yeah, we're less than 30% to pick that up. That would be very surprising to me. That's why I would say this was the wrong decision to kick the field goal. Yes, it's true. You need 2 scores. One of them a field goal, one a touchdown. At least 2 touchdowns would be better. That would be for the win. But it doesn't mean you have to settle for the easier one. You will win more often by running a 4th down play if you think you're at least 30% likely to pick up the 4th and 3. That's why I say the Raiders made the wrong decision to kick this field goal. So the field goal goes through, and the Raiders think they got closer to winning, but they actually got closer to losing. But the main thing I want to talk about is, yeah, there are a lot of unknowns when I do these calculations, and you need to estimate probabilities that you can never even know for certain. But the answer, if you don't know any of those inputs that I put into those calculations, the answer is not ditch this and just guess and do whatever you want and then talk about it later in a press conference after you lose. This is the framework to do it. This is the correct way to make these decisions. If you're not good at estimating these probabilities, get better at estimating these probabilities. It's not difficult. The probability of winning is the product of the probabilities of every event that you need to go your way. So when I spell that out, you are going to kick a field goal here. If you're the Raiders, you need those 4 things: the field goal to go through, getting a defensive stop, scoring a touchdown, winning in overtime. That's it. You multiply those 4 probabilities together, and that is your probability of winning. It's that simple. The difficult part is estimating the probabilities. You should have someone on the sideline who can do this math in game and tell the head coach what to do, field goal attempt, or run a 4th down play. Head coaches are terrible at this. You should have someone on the sideline who could estimate these probabilities and do these calculations and tell the head coach what to do. If you're not going to have someone on the sideline, this would be plan B. The head coach should go based off of instinct and decide what to do, field goal attempt or run a 4th down play. But either way, afterwards, go back to your office and do this math and decide, was it the right call or not, so that you only get it wrong once. If you get it wrong the first time, the math doesn't confirm it, and you get it correct every time after that.